And welcome, everybody. My name is Brad Closa. I'm the program director of the IEEE Future Networks Initiative. If you're not familiar with IEEE, we are the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Before we begin, I'd like to explain the format of this live event on LinkedIn. Our panelists will speak for about 30 minutes. After that, we'll then select some questions from the comment section in the LinkedIn chat feature. So please feel free to submit any questions you might have for our speakers in that comments field, and we'll go through them and ask as many as we can. But now we can begin. This is the third in a four-part series for LinkedIn Live called 5G Demystified. It's a special collaboration between IEEE Future Networks and IEEE Educational Activities. The first two sessions are available to view on demand, and I believe in the description of this event, you should find links to those. Today's episode is called Health and Safety of 5G. From a public perception standpoint, 5G technology can't seem to catch a break. Various internet theories have tied it to cancer, then COVID-19 virus, and then the US Federal Aviation Administration claimed it could endanger airplanes landing in low visibility. So in an era of increased propaganda and misinformation, how are citizens and non-technical policymakers supposed to make any sense of any individual claim? In this IEEE panel discussion, experts will discuss the science and standards of human health effects from electromagnetic radio waves and 5G communications. This time, I'd like to hand it over to David Witkowski, who will lead us through the panel discussion. David is founder and CEO of Oku Solutions, a professional services company that works at the intersection between local government and the telecommunications industry. David is an IEEE senior member and a member of the IEEE Electromagnetic Compatibility Society, a life member of the IEEE Microwave Theory and Technique Society, and is co-chair of the Deployment Working Group for IEEE Future Networks. Thank you, David. Please take it away.
Thank you, Brad. I appreciate the opportunity to be here. Welcome to everyone who's in the audience. I think this is a really interesting discussion, certainly because this is one of the, obviously, probably the biggest thing that I deal with in the course of the work that I do. Working with local governments, working with community groups, working with the industry to try to bring some rationality and perspective into this often discussed topic. Anybody who's been on social media or had conversations with neighbors in your community probably has heard from somebody who has concerns about 5G or other wireless technologies. And so this is a very often talked about topic, and I think it's also a often misunderstood topic. So I'm really happy to have such an august panel of experts with us today. These are the people who contribute to the science behind this topic, and so the opportunity to hear from them today is really unique, and we're looking forward to doing this. So in no particular order, I'm going to ask the panelists to introduce themselves. And just because this happens to be the way it shows on my list, I'm going to start with Brad Roth. Brad, please give the audience an introduction to yourself.
Hi, I'm Brad Roth. I went to Vanderbilt University to get my PhD in physics, so I'm a physicist. Then I worked at the National Institutes of Health for 7 years, really applying physics to medicine and biology. So I've worked measuring magnetic fields produced by nerves. I've worked on transcranial magnetic stimulation of the brain and on pacemakers and defibrillators for the heart. All these things tend to be at somewhat lower frequencies than what we're going to be talking about today, but there's still a lot of common aspects that come into play in how electromagnetic fields influence the body.
Thank you, Brad. Ken Foster, please let the audience know who you are.
Hi, I'm Ken Foster, Professor Emeritus of Bioengineering at the University of Pennsylvania. I've been involved in this field in one way or another since 1971 when I got my PhD in physics. I initially worked for several years in the US Navy Medical Research Institute on biological effects of radio frequency fields. And after moving to the University of Pennsylvania, I've been involved in one way or another with this field ever since then. I'm a life fellow of the IEEE, registered professional engineer, published many papers on various topics.
Thank you, Ken. And last but not least, Dr. Bushberg.
Yes, hi, David. I'm Jerry Bushberg. I'm a clinical professor of radiology and radiation oncology at the University of California, Davis School of Medicine. I also serve as the vice chair of COMAR with the IEEE and the Engineering Medicine Society committee, which deals with helping to explain otherwise very complex, some often controversial issues regarding RF energy. Because of my academic appointment, I have to make sure that I state that the statements that I make today are based on my own expert evaluation and opinions and don't necessarily represent the views of the University of California or any other organization that I am affiliated with. Thank you.
Thank you. Appreciate you all being here. So I'll do a quick open comments, and then we're just going to go right into the questions. So certainly wireless connectivity has changed our world. It's changed how we connect with information and each other. And this use of the wireless network has placed a lot of pressure to deliver higher performance. In order to create that level of performance, the operators and carriers have had to densify their networks, adding facilities, towers, and small facilities closer to population centers. Unfortunately, this placing of equipment near population centers has led to concerns from residents about electromagnetic fields, RF energy, which are emitted from these sites in order to perform their functions. And those residents tend to show up in local governments and agencies demanding that projects be delayed or even halted. So despite the fact that our population clearly has voted with their dollars to use wireless technology, there's an increasing outcry about the mechanism by which it is delivered to the population. Some countries, in an effort to accommodate these concerns, have adopted precautionary guidelines that are above and beyond what the core science and the core standards, such as the IEEE C95.1, recommend. But without reference to any particular science or medical evidence, some local governments have actually enacted ordinances which explicitly or implicitly prohibit technologies such as 5G or networks that use millimeter wave frequencies. Others have enacted distance limits, basically excluding around population centers, whether it's schools or residences, without regard to the amount of power that the sites actually put out. And so all of this really sets up a problematic situation, which is that clearly there's a lot of people that want to use this network. The ordinances and codes, or the way that this is implemented at the local level, is being driven by perception as opposed to science, and opposed to clearly defined mechanisms that are based in standards and reviewed, high quality reviewed material. And so if we can't get past this, then it's going to be very hard to deliver these to the people who want these networks. And certainly we've even seen some criticism in the industry that, the 5G network is not rolling out fast enough. But I would argue that based upon my experience, this is because these are hard to get done just because of local issues. So let's start by level setting this. And I'm just going to throw the question out to the panelists in no particular order. First of all, let's discuss what is new about 5G. And the reason I ask that is because 140 years ago, people were afraid of electricity because it was new. As new technologies come on the market, they tend to generate concerns. So historically, we've had fears about everything from Wi-Fi to electric blankets to blue LED light bulbs. What is it about? What's new about 5G, and why do we think why does the panel think that 5G is causing concern? I'm going to ask Ken Foster to address that question to start.
Well, first of all, 5G is simply a different technology for wireless communication. It's not a different physical property. It's, in fact, an evolution of 4G using similar technologies. The main differences are, first of all, it provides the users with a much broader bandwidth so they can transmit more data more quickly. It uses different frequency bands, two of which are very close to similar to existing cell bands, one of which is close to the millimeter wave at higher frequencies. It allows much faster transmission of data more efficiently than existing cell phone technologies. But as a result, it's going to require more base stations than existing technologies. That accounts for many of these small cells that are located in the cities. So it's the exposure characteristics at the two lower bands are similar to those of existing cell phone networks, perhaps even a bit lower. The exposure characteristics at millimeter band are also similar to those, quite low compared to the existing standards, but in a different frequency range than presently used. So I think the answer is there's not much different.
Thank you. Brad, do you want to offer a comment?
Well, there isn't a lot different, but one thing that as you go up in the frequency range, you tend to have a difference in penetration depth. Sometimes electromagnetic fields at lower frequencies can penetrate the body more easily. As you go up higher, they can't penetrate as easily. So in some ways, you don't have as many problems with real deep parts of your body being stimulated at these much higher frequencies because the electromagnetic waves just can't get in there.
Yeah, I'd also mention that these are beamforming antennas that are directing the energy in a relatively tight beam to the user who is requesting service. And unlike previous generations where RF fields were basically out there in a particular sector, and if you had a device and could connect, that energy was there most of the time, whether there was a user or not. In this particular case, if you were an AT&T customer, for example, and you were walking by a Verizon cell site, the exposure, the only exposure would be from the scanning beam, which is a very small part of the total energy, and maximum or the typical exposure would not occur because the cell side would not be sending a signal to you because you're not a customer of theirs. So it's really quite selective, and in many cases, I think reduces exposure to areas where these sites are deployed.
Yeah, it's and I tend to agree with all of your comments here. The thing that I see happening, which I think is of concern, is that people are lumping in 5G with millimeter wave, which is new to cellular. But for example, if you were to deploy a 5G radio in the old 850 megahertz 1G band, there's nothing particular about 5G that's different. It doesn't automatically create some new health issue because you're modulating that frequency with a different information. And I think that people are conflating 5G with millimeter wave, which is new to the cellular usage. So really, I think what we're talking about here today is actually the question of the safety of RF energy. And its health effects on humans and animals. So let's pivot to that. So we often hear, especially in community hearings or appeals, we hear about various studies. There's the Bramazzini study, there's the National Institutes of Health, National Toxicology Project, what's often referred to as the rodent study. There are others that have been set forth. Many groups cite these as showing evidence of concern and that there should be constraints. But let's talk about, in general, how these cited studies fit in with the overall body of evidence around this topic. How much study has been done on this topic? How many years have we been looking at this question? Ken mentioned that he's been doing this since 1971. I know it actually dates back to the 50s. But what's our best understanding of science regarding RF safety? And I'm going to ask Dr. Bushberg to start off.
Yeah, well, I think it's sort of an overarching issue, which is very important to understand, is the complexity of research in this particular area, because not only does it involve the typical kinds of, and for example, animal assays or cells, the typical kinds of biological assays that many biologists and people that work in toxicology are familiar with. But what they typically aren't familiar with, and what's really quite new and leads to sometimes some erroneous publications, is the engineering part, where they expose either the animals or the cells, and without appropriate and pretty significantly detailed analysis of the potential exposures. There have been many examples where the exposures reported in the literature turned out to be many, many times lower than the actual exposures due to misinformation about how the RF energy would interact with a particular cell sample. So I would just start by saying that the literature is messy in this regard. There's a lot of literature that is not as high quality as you would like to see. And that, together with the nature of the predatory journals that allow you to publish even a flat Earth paper, if you wish, if you pay the fee, creates a problem for someone just searching on the internet. So I think that's sort of an overarching issue. But we have been studying biological effects of non-ionizing radiation for over, maybe 60 plus years now. But I would say that I would characterize it by saying that the research in the past several decades is of much higher quality in most cases than the prior publications. Although there are many excellent publications in those prior, but there was also, I think, less quality control with regard to the engineering, and that has been improved to some degree.
Good. Brad, do you want to offer a comment, and then we'll go to Ken?
Well, I think there's really 4 types of evidence that we're looking at. There's brain cancer trends, and brain cancer incidence has been flat, although cell phone use has skyrocketed. There is epidemiological studies, and although there are some questions in early studies, most of the epidemiological analysis looks like there's not a large effect. There's theoretical analysis of possible mechanisms, and there's no support for a lot of these mechanisms of biological effects from theoretical support. And the last issue is the experimental laboratory studies, and that's where you get the big mixed bag of results. So I think as long as we have this confusion and inconsistent results in the laboratory experiments on cells and on animals, it's going to continue to be controversial.
Now, you mentioned the epidemiological studies, and those are not free from confounding variables as well. In fact, epidemiology in and of itself, studies the organism of interest, which is great, right? It's evaluating human exposures and disease and causation. But as many of you know, but some may not, this is particularly a problematic area of epidemiology in RF because, for example, ascertaining what definition of exposure and determining what person's exposure to wireless communication frequencies and different modulations and intensities over a given period of time, and epidemiology spans decades. And asking people to recall, for example, how much they use their cell phone on what side of the head, especially if they are infirmed or have brain cancer, and have undergoing treatment, so that their mental acuity may not be as great as it used to be. These present not insignificant hurdles to providing high quality epidemiology the way you would otherwise want to.
Ken, you want to comment?
Well, I'm not especially. When I first got into this field in 1971, working for the Navy, the main interest of the sponsors, the Navy in those days, was occupational safety.
Sure.
Navy wound up with a lot of ships with huge radio frequency antennas and lots of sailors who had to work close to them. And so the initial motivation for this work, going back to the 50s, was occupational safety. And that's still a factor for people who have to climb towers, work near antennas, and so forth. And the hazards that were identified in those days, burns and what have you, really are the hazards that underlie the current exposure limits. And despite the fact that research over the years has shifted more and more towards environmental exposures from low-level sources, those still are considered to be the dominant hazards that have to be protected against. I think part of the problem is that there have been, at this point, several thousand studies looking for biological effects of exposure with endpoints that vary tremendously in relevance to health and studies that vary tremendously in quality. And so the noise level in this literature is high, and even experts themselves sometimes debate what the significance of many studies are. So it's not a simple matter to explain.
I agree with that. And I think, people sometimes say, well, this is the new cigarette, and they thought cigarettes were safe. And so now we have this new thing, and we're going to find out later that it's not safe. But that analogy is quite flawed. You know, I mean, even if you were to assume that the epidemiology was done in a pristine way and had no confounding variables, which in fact is not the case, when you look at the relative risks associated with those studies that are positive, although there are many that are also negative, they're relatively low. These relative risks are in the area of 2, 3, 4, 5. If you look at lung cancer and cigarette smoking, the class of studies done by Sir Richard Dahl et al., the relative risk factors there are 15, 20, and even higher. So the signal was dramatically clear, and it also was a consistent evidence. All of the studies that were done over those periods of time only made the connection between cigarette smoking, lung cancer, and other cancers even more certain. So there wasn't this back and forth necessarily in the literature about whether indeed there was a correlation, and later studies helped to define causation of this particular agent.
I agree with the comments. Certainly in my time in the U.S. military, as our radio and radar, technician and working on those systems, we were aggressively told to be very careful about this, and the issues that occurred during the post-World War II era with especially with radar were drilled into our heads. I thought the comment about predatory journals was really interesting, because we get a lot of citations when I do hearings. They'll say, well, here's this paper that shows blah, and it was on a government website. It was listed on the some federal website that aggregates papers. Well, was it a good study? Right? Was it was it a well done? It's like, well, it was, and it sort of comes across as, well, it was on the internet and it's a government website, so therefore it must be true. And I think the public, variably has the ability to sort through all of this. But of course, the internet makes everybody an expert. So that's been a little bit unfortunate.
David, you raise actually a very important issue, which is, how is the public supposed to digest this information?
Right.
Who are they to turn to? Who are they to believe? And first of all, you have to, understand that there's no one publication or individual that can opine with absolute certainty. And in fact, science in and of itself is not an absolute domain with regard to truth. There are always open questions and things that we continue to explore. Right. However, if you're going to assess the biological effect of any physical or chemical agent, what you need to do is to assemble a team of scientists that have the relevant expertise in all of the various disciplines, both in terms of toxicology as well as engineering, cancer biology, molecular genetics, et cetera, to be able to evaluate the papers with regard to their quality. People that actually do this particular work, maybe with other agents, are keenly expert in assessing whether or not the techniques and even the statistical analysis that was performed are appropriate for the particular paper that's being presented. And when you do what's referred to as a systematic review, where you set up the criteria by which you will accept papers of the highest quality or grade them, so from high to low, you find that when these are done well, the number of actual papers that make it typically less than 10% of those that are evaluated.
Let me double click on what you just said, because I think it's really important. The process by which you describe is actually how the IEEE C95.1 standard is updated on a regular basis. Many times in hearings, we hear from opposition groups that, well, the FCC hasn't updated its guidance since the 1996, back when the StarTAC was the dominant technology, right? The 1G flip phone. And so I think what you said is really important, which is that all of this review and this expert body, this goes into the IEEE C95.1 standard, which is then used by agencies, including the FCC, to create their guidance. Is that correct?
Well, I think all of the, whether it's International Committee on Non-Ionizing Radiation Protection, or ICNIRP as it's most commonly referred to, or any of the other really dozens and dozens of scientific councils that have been assembled to review the literature, all do that same thing. Some do it better than others, but in general, they're looking to first assess the quality of the literature in that area, so that they are making decisions on those papers which have the highest confidence in providing a good connection between the evidence that's presented and the conclusions that are drawn.
Yeah.
If I could jump in, I could point out that there are some scientists out there who would vehemently disagree with everything we're saying, who are absolutely convinced that radio waves, even at very low levels, such as from Wi-Fi, are very dangerous. And I've spent a lot of time trying to understand their arguments, and the best I can come up with is that they're looking at the same body of data from a different perspective. Health agencies generally, in fact, uniformly haven't expressed any concern about hazards from ordinary environmental level exposures, because they do basically, like Jerry has been talking about, they review the literature with respect to quality and try to put everything together and see what comes out. And the answer is not much comes out consistently. You can take a different point of view by going through each study that claims an effect, and maybe half of all bioeffect studies do claim some kind of effect, and then sort of cherry pick and wave your hands and come up with a story that can tell the public that the world is coming to an end. Yeah. In fact, I know of one professor who's actually making those statements to the public, that 5G will create an end to human civilization within a few years. It might happen, but probably not because of 5G.
Yeah, and there's an important distinction between, when you run a study, especially in the laboratory, between observing an effect and an effect that is potentially harmful to human health. Many things, when tested in these kinds of experiments, cause some sort of physiological or cellular mechanical change. But the human body and all animals have very robust adaptive responses. When we take in food and convert it to the cellular energy ATP, there is a very hostile biochemical process known as oxidative phosphorylation that takes food and turns it into energy, during which there are dozens and dozens of changes in metabolites and in cellular homeostasis that are dealt with by the body very effectively. And so just because you can demonstrate a change in an isolated cell or in an animal doesn't mean that necessarily would lead to an adverse health effect in humans.
It's interesting you talk about the body's adaptation to this, because Brad, you wrote a book on this topic, and one of the things I remember from your book was you talked about how the induced fields from RF energy relative to the electrical fields which already exist in the human body from cellular processes and nervous processes are that the human body's fields are so much larger that this is an insignificant amount of energy relative to the simple operation of the human body. Do you want to make a comment on that?
Yeah, that's true. There's not a whole lot of radio frequency energy that the body's producing, but a lot of the ideas of mechanisms of how the radio frequency energy couples to the body assumes that the radio frequency energy is modulated. Just like in AM radio, the amplitude modulate, and if you can demodulate it, you can get down to where you're now operating at more kilohertz type frequencies. And that's where you have electric fields from the heart, electric fields from the nerve, fairly large electric fields already existing in the body. And you'd have to have, as well as thermal fields at any frequency. And you really have to be careful if you're dealing with really weak field effects. It's going to be swamped by the endogenous fields in your body.
And Christopher Cobden Davis from University of Maryland did some interesting research on this topic, where he showed that the human body could not demodulate. And I'm slipping a little bit into engineering here, but the idea that the human body could respond to the information that's carried on. And so this really gets to this question of, like, are we concerned about 5G itself, like as a modulation method? Is there something about the waveforms which are problematic? Or are we simply talking about the photonic energy that dissipates in the human body? And Dr. Davis's work, I think, was very clear on this topic, that anything that dissipates in the human body is going to be resistive effects, meaning that it's heat. And that's what we have found to be the impact from RF energy. The one proven thing from RF energy has been that the body will, subjected to enough energy, will heat up. But then again, when I go outside on a cold morning and stand in the sun and drink my coffee, I'm absorbing photons and that's where the heat comes from. Comes from that big electromagnetic generator that we orbit called the sun. I think that one of the things that it gets to that question of sort of scale of impact, and Dr. Foster, you wrote an article in IEEE Spectrum a while back about this question of dose versus exposure. A lot of the citations that we hear in these hearings about concerns, stuff that people pull off the internet or off of paper aggregation sites, deals with this. Well, the NIH rodent study showed this, but I'm afraid of a cell site that's 200 feet away from my house. Obviously, the power levels are extremely different between those. Talk to us a little bit about dose versus exposure, and how should people interpret a study that says that holding my phone to my head is problematic, and how should they interpret that in the context of a cell site that's some number of meters away from their home?
Well, exposure technically means how much energy is incident on your body, the intensity of the field. Dose is how much is absorbed. What you're probably asking about is why is it that some sources produce much more exposure or much more dose than others? It's been pretty well established that the major source of exposure to an average person from radio waves comes from when they use cell phones. Below that, there are many other sources, including base stations located outside the home, Wi-Fi, microwave ovens in the home, and so forth. And so the major source of exposure is from one's own use of cell phones.
Followed by Wi-Fi access points in the home, I would guess, right? That's probably right. Like number two.
And many other sources. When you use your microwave, you're bathing the entire home in very weak microwave energy, and so forth. So in my mind, it's not too sensible to worry that exposure from base stations located 100 meters down the road when you yourself use a cell phone.
Yeah, to follow up on that, I think it's a really important point, and one of the things that's sort of counterintuitive that people don't recognize is that the phones have this function called adaptive power control that changes the output of the phone based on the strength of the signal from the cell side, and the difference in potential exposure from the phone can range over 2 or maybe 3 orders of magnitude depending on the particular modulation.
And in fact, I'm sorry.
No, and I just wanted to make the point that if you really want to reduce the amount of exposure from your phone or from phones that are being used next to you, what you really need is good coverage in a network so that everybody has a good signal from the side and their phones are operating at the lowest possible level. That would, just from a logical perspective, if you were concerned, that would be a goal that you would want to see achieved.
That's a really interesting point. Having worked on as an RF engineer in a company that developed handsets, at one point I have worked on adaptive power control, both on the receiver and the transmitter. And we know this, and people experience this every day. How many times have you gone hiking and your battery dies for some reason? You wonder, well, why did my battery die? And the reason why was because you were out in the middle of nowhere and your phone jammed the power up because it couldn't contact the cell site. So when you have no bars or 1 bar, your phone will try to connect, which of course means that it's emitting more RF. And as Ken pointed out, right, that's the biggest exposure of RF in your life is that phone that you tend to carry in your hip pocket or your breast pocket or on your belt. So let's switch a little bit to away from this topic of so obviously everybody has probably heard about this argument that RF fields cause cancer. That was the thing that was many years ago was asserted. That it was carcinogenic, but as I believe it was Brad pointed out, as our usage of wireless devices has increased exponentially, cancer rates are actually dropping. Right, that they're either flat or dropping. So the two are not correlated, and as a lawyer would say, that which is correlated cannot be causal. In other words, if cancer rates are not going up commensurate with the amount of usage of our RF devices, then phones are not causing cancer. I tend to see that now a lot of the opposition groups come into these hearings, and they're claiming other effects. I've heard it. I've heard RF energy blamed for autism in children. I've heard it blamed for ADHD in children. I've heard it blamed for diabetes, headaches, nausea, anxiety, all these electromagnetic hypersensitivity effects that people tend to list off. And of course, there was that doctor out of San Francisco who is no longer a doctor as the state of California removed his license. But in the early days of the pandemic, he claimed that 5G caused COVID. So let's talk about that. So I'm going to start with Ken. What is your take on this shift away from carcinogenic effects towards these other effects, particularly centered around these sort of non-specific health concerns that might be classified under a lump term of electromagnetic hypersensitivity?
Okay. Well, in the public, the two major issues that keep on being discussed are possibility RF energy causes cancer, and that's been pretty much considered by health agencies. The other one is what's called electrical hypersensitivity. People feel in some way that they have non-specific responses to even low levels of radio waves in the environment. You could think of this in layperson's terms as being allergic to Wi-Fi, for instance. This issue became very big in Europe in the 1960s, 1950s, when people felt themselves allergic to video display terminals, power lines, fluorescent light bulbs, and so forth. And then as the wireless revolution took place in the 1990s through 2000s, people developed what they thought was a sensitivity to radio waves. The problem is that there have been many studies trying to determine under blinded conditions whether people actually can detect when they're exposed to radio waves. And the answer is that no one has been able to identify any clear-cut response that people have when they are exposed under blinded conditions. Nobody really knows the cause of this. The two dominant theories are it's maybe some sort of psychological response called the nocebo effect, or the people themselves are absolutely adamant that this is a physiological response to these fields. The problem is that the fields that they think that they're responding to are exceedingly low. One man sued his neighbor because he thought his Wi-Fi system was making him ill. And if you're going to try to set exposure limits to protect against that kind of exposure, you might as well just turn off the whole radio spectrum. But unless
I would add that it's not, it's not unique just to RF either. There are, a number of cases where people believe that the cause of their maladies is due to not just RF, but any number of potential things in the environment, or the chemical plant down the road, or the amount of asbestos that might be lingering in a building, that sort of thing. And so these correlations, not necessarily causations, are not, and that is not a new phenomenon. Also, I think it's important to understand that these people do suffer. I mean, they're not making this up. I mean, they're really impacted by whatever it is that is causing the symptoms that they're experiencing. It just doesn't appear to be in controlled experiments due to whether the exposure is from radio frequency energy or not. And David, one other thing I wanted to go back and just clarify when you're talking about cancer, because I think we have to be very careful, what we say in this regard. Certain cancers have been increasing over the years, and others have been decreasing. And so when we're talking about RF and cell phones, I think we want to stick with, specifically those that have been indicated or implicated, like glioma, for example. And if you look at that particular cancer, between the early 1970s and mid 1980s, there was a significant increase in the incidence of gliomas. Now that was before the cell phone era, and it was largely due to the introduction of MRI, RCT, and its widespread use in medicine, which was increasing the incidence of identifying these tumors in individuals. But if you look after that, during the period when there was over now more than 100% penetration in most countries where most people own cell phones, and followed from that period, there's been a slight decrease in gliomas overall. Now, individuals have taken very, very small slices of very, very small segments of some country and shown an increase. But when you look at the totality of the evidence, it doesn't suggest that there's an increase in gliomas over the period in which cell phones have been proliferating.
Thank you. Brad, do you want to comment?
Well, I think going back to something you said right at the start of this event is that historically, electric and magnetic fields have been identified as health hazards going all the way back to Mesmer and animal magnetism that Ben Franklin's helped debunk. The 60 hertz power line was huge 30 years ago, and magnets, wearing a magnets in your shoe to alleviate pain. And you have to forgive us. Some people like myself who have been involved in and watched these things, there's just a temptation to say, here we go again when we hear 5G now as proposed to be these health effects.
Yeah, I think, Brad, it's important to understand that when, give the magnets as an example that you raised, there are people that will swear by those that say, when I wear these, my arthritis is better, my, whatever condition they're trying to, and there's no doubt that a placebo effect doesn't mean that it isn't real. Placebo effect just means that it is experienced by the user, but not necessarily related in a scientific way or a cause and effect way by the instrument or the drug that is being taken. But your body is and from a neurobiological point of view, is a very powerful instrument, and a strong belief that A causes B and a symptom B can cause symptom B to appear even in the absence of a direct causation, just from the neurophysiological connections that are very robust in our bodies and are able to produce a wide variety of chemicals that have real effects.
Yeah, the problem though is that some of these people are affected to the point where they simply cannot live in modern society. Yeah. There are people who live in caves in France to get away from electromagnetic fields, or they move to a small town in West Virginia where there's a space telescope that doesn't allow cell phone service. So these people are seriously suffering, and the problem is that there's no clear way of treating them, and there are all sorts of people out there who are taking advantage of them by selling them literally tinfoil hats and so forth.
Right.
And so these people are not being well treated by society. There should be some clinical trials to find ways to effectively address their concerns, if not treat their disease.
Yeah, Ken brings up another part of this problem, which is the entrepreneurs that that sell fear as a commodity, and it's a pretty good business model. Fear sells, and the devices that they suggest are either not effective or can actually result in higher exposures, as we experienced with some of those cell phone covers in the early days that also caused the cell phone to need to transmit at higher levels to make the connection. So it's not it's not a innocent endeavor. It causes harm both psychologically to people and provides very little benefit.
Yeah, that's a really good point. It's unfortunate there's this huge industry around this topic, and many times in these hearings that we support, we'll have people come in who will be accredited by various organizations or what appear to be institutes of higher learning that are actually led by their board of directors or their board of advisors, engage in a robust business selling all kinds of snake oil about, as you pointed out, cell phone cases that protect you from RF. I've seen dirty electricity filters as another one. I'm not sure how electricity gets dirty, but Wi-Fi access points that are claimed to be somehow safer than regular access points, and of course cost 4 times as much. There's a variety of things. I remember people at one hearing were talking about how they were wearing pendants, which are made of a material that's I think it's called shungite, which is this basically carbon but it's actually radioactive. So if you pass a Geiger counter over a shungite pendant, it will set it off because it's actually radioactive. So because they were afraid of Wi-Fi that was operating in the building, they put on something that was actually radioactive. Because of the kind of the pseudoscience woo around this that they believed was going to make them, because it was engraved in some sort of a mandala that was going to somehow or another deflect the RF fields. And that's really unfortunate, because people are spending an enormous amount of money on this rather than, addressing the core problem, which is perhaps psychological or other mechanisms.
And to that point, another area that this falls into is when people purchase RF detection instruments off the internet or from eBay.
Yeah, sure.
And some of them are just extraordinarily sensitive to
Yes.
any electric field, whether it's an RF field or not. And they have just painted on the dials, a green for okay and red for really bad or hazardous, and holding it up to virtually anything that produces an electric field. I know regardless of how small, will cause the needle to go into the red. But these are not scientific instruments, do not have the kinds of calibration and units or reporting that are can be used in any way to assess the relative hazards of exposure.
Yeah, we had one of those show up in a hearing recently where somebody said that their safe or their particular brand, forget the name of it, was, that it showed these huge numbers, and relative to the $12,000 NIST calibrated instrument that I use in my work, right? There's a several orders of magnitude of accuracy that $12,000 affords you. And just having some sort of diode detector is not the way, but people believe that this is true. As I recall, I think you could even, some years ago, you could even go into Home Depot and buy one of these devices for, $100.
And David, even if you shell out the $12,000 for the appropriate instrument, you need to know how to use it.
You have to understand how to use it. That's exactly right.
Because you can get spurious readings from a number of
Yes.
aberrant conditions if you're not really understanding the technology and the ways to avoid those kinds of spurious readings.
Right. We're probably about 13 minutes away from the top of the hour, and I know that we're going to have to do the wrap on this. So I would like to begin talking to some of these questions which are in the chat. And so one question came in from Marie Smurman, who asked about Havana syndrome. And I had asked the IEEE host to post a link to Ken's presentation on this topic. So as you had noted this, so Marie, if you want to go, I don't know if you're a Twitter user, but if you want to go to @KFosterUPenn, PENN, that would be a way for you to get access, because it's a pinned tweet in Ken's Twitter feed. So if you are on Twitter and you want to try to access his Havana paper, then that would be a way to answer that question. I think it's a bit beyond the scope of what we're talking about here. Another question had come in from Alan Jones. And he had asked the question, if I stand 1 meter from a 5 gigahertz Wi-Fi router, would the field strength be greater than from a typical 5G base station situated perhaps 10 meters away? And he says, because people are concerned about field strength and not realizing that Wi-Fi may actually be a stronger signal. And I think it's hard to answer that question, Alan, because a typical 5G base station unfortunately is not typical. It depends upon what we're discussing. Are we talking about a macro site? Are we talking about a building mount macro? Are we talking about a small cell, a micro cell? And which frequency is it operating at? Because of course the strength of RF fields dissipates as both the square of the distance from the source, as well as the inverse square, I should say, of the source, and the distance, or the inverse square of the frequency. So if we're saying a 5G site that's operating in the 700 megahertz band would have a very different propagation characteristic from the dissipation that would occur at, say, 28 gigahertz in the millimeter wave. So,
But David, I think what we can say is that under any of those conditions that were described, the amount of exposures would be exceedingly small and represent maybe 1,000 times or 100 times less than the standards would allow for continuous public exposure.
And that's a very good
really I think the way to maybe a way to characterize it is that they're both low. How they would compare may not be that important.
Yeah, that's a very good point, Dr. Bushberg. Thank you for bringing that up. In the work that we do when we go out, I mean, we get asked to go out and do field analysis quite often. And when I go out, often it's, the numbers are like sub 1% for the exposure level that is defined by the standards and by the safety guidance. Most of the time it's certainly nowhere near anything even double digits. It's probably often less than 1%, even when you're rather close to the source. And that's just because the RF fields fall off very quickly as you move away.
If I could add, though, Wi-Fi is a pulse signal with extremely low duty cycle, so the time average exposure is very low. While that from a base station is pretty much on all the time.
Right.
And from a psychological point of view, the exposure to a base station radiation is involuntary, while that from Wi-Fi is strictly voluntary. So there are psychological differences too. So from a public perception of risk, these are very different exposures, even though numerically, in some respects, they may be comparable.
That's a very good point, which is that people do make the assertion in many of these hearings that they have no control over this, and they feel like it's being forced upon them, as they could make a choice to turn off a Wi-Fi access point or turn their phone off if they had concerns. And so there is a certain amount of sense of intrusion, if you will, into their lives, right?
But David, I would suggest that you have to look at these issues from a holistic perspective, and from a community public health and safety perspective. The number of lives saved, the number of people who lived rather than died from automobile accidents because of wireless technology and ability to summon aid quickly or to provide care from a physician remotely. This is not a statistical analysis that there's a debate about. The vast majority of 911 calls now come in through wireless communication, and the public benefit, even if you set the economic benefits aside, the public benefits in health and safety are undeniable and demonstrable. And you compare this to the possibility of some risk at very low levels that is yet to be identified.
Right. So turning to a question from Story Pellicero, who works in siting, and she asked the question, what arguments or statements have you found to be most persuasive or resonate the most with local governments and residents? I think, Story, the answer to that is that it depends. It honestly depends upon the jurisdiction that I'm dealing with, and I'm sure Dr. Bushberg, Brad, Ken, you've all done work in this area. You would probably agree with me that it really depends upon what the concern is, and then you would have to address that. So understanding the jurisdiction and then coming up with logical and science-based responses to that is really the core of the work that is done in this area, which is why people such as yourself ask people like us to come in and help with this, because we do immerse ourselves in this topic, and we're able to pull out that evidence which is necessary to deal with some of these refutation of pseudoscience. But of course, Ken, go ahead.
I'm a registered professional engineer and sometimes do assessments of compliance with proposed transmitters with FCC exposure limits. I haven't done that in the last couple of years, but I've done that in the past. And I've made many public presentations, and I've discovered the worst thing to do is to say, I'm an engineer, here's the science. It's much better to say that these issues have been studied many times by health agencies, from the World Health Organization down to many national health groups, and here's what they invariably find, and there's no clear evidence of the harm. But you don't want to say to opine about scientific issues, nor do you want the engineers for the site acquisition companies to stand up and say, I'm an engineer, here's what the truth is. Because
I think
they have credibility.
the answer lies somewhere, I think, in the middle. If you're asked a very specific technical question, of course, you need to respond to that. But you cannot debate the science in those kinds of forums. It's not only not practical, it's not appropriate, because the people with necessary knowledge to opine on whether certain evidence is credible or not, are not present to provide the necessary perspective. So I think you have to back it out to much more general sorts of issues. Ken mentioned one of them being the fact that there have been many institutions and countries that have selected scientists from their various universities to opine on this topic and have come to essentially the same conclusions. And then I would add the fact that the item that I mentioned about the positive societal benefits of wireless technology. And I think these are concepts that resonate more clearly with the public than any in-depth scientific debate on a particular issue.
Yeah. I generally tell the public that people can choose what they worry about. And if they want to worry about RF fields based upon some activist statements, that is their prerogative. From a point of view of setting public policy, you're better off choosing to put weight in the World Health Organization, National Cancer Institute, Food and Drug Administration, or even just pay attention to the legal constraints and simply not try to get in over your head in analyzing this very complicated scientific issue when these have already been well discussed by health agencies.
Let me just add one point to that, and this ties in directly to what has been said previously. I explained to people that when my kids were young, we had a baby monitor so that my wife who was downstairs could hear the baby cries. Although with my kids, you could hear them without a baby monitor. You really didn't need that amplification, but she felt more comfortable with that. And so, knowing my area of expertise, she asked me, if I thought it was okay, and I said, well, yeah, I measured the levels and they were very, very low, and said that she feels more comfortable with that, having that ability to listen in. So I made a personal choice based on my own scientific understanding of the issues and my concern for my own family. So I think if you can add any personal anecdotal information that relates directly to decisions that you've made, sometimes that's helpful in placing things into perspective.
I think it's a question. There is that question of relative risk, and I see Brad has come on, which is the signal that it is time to wrap up. I'll close out by saying that a lot of these things are questions of relative risk. If I go to a hearing and there's a lot of people there, sometimes I will ask the question, how many of you drove here today? How many of you rode your bicycle? I mean, the reality is that there's like a 1 in 100 chance in the course of our lifetime that we will be in an automobile accident. It's being in a car accident, being in a bicycle accident is a far more likely event, an adverse event in your life over the course of the years that you're there, out driving around, versus say, some random exposure to an RF field is going to cause a health effect. So we have to. I think we have to say that we accept a certain level of risk in our lives, just simply getting out of bed and getting in and walking to the bathroom. But we don't think about that because it's a normal thing for us. Brad, I'm gonna turn it back to you. Panelists, thank you so much for being here. It was great. Always appreciate having a conversation with you folks, and glad to do it in front of an audience. And really appreciate the IEEE being willing to host us for this. You're welcome to reach out to any of us on social media if you have follow-ups or you want to engage with us, any of us directly. Brad, why don't you play us off?
Thanks very much, David, and thanks as well to the panelists from me. Having your expertise on this topic is greatly appreciated. I'm sure the audience agrees. And thanks to the audience as well for tuning in. If you want to join our next episode of this 5G Demystified series, just look in the description field of this event. You'll find a link. The next one is going to be called Will 5G Kill Wi-Fi? It will go live here on LinkedIn on December 15th at 12 p.m. Eastern Time. And to learn more about 5G and how it could transform industry and society, please visit the Future Networks Initiative online at futurenetworks.ieee.org. Thanks, and have a great day.
Thanks all.
Thank you. Take care. Bye-bye.
Okay.